just a camera, it is just a lens, how it is detecting my face, right? That is all because of the artificial intelligence program running on the camera application where the face is, right? So let's see how it is recognizing the face, right? First, it has to understand how the face will look like. Basically, for human, the face will be something like it will have two eyes, and the size of the eyes will be something like this, and there will be a nose behind that. The nose of the size will be something like this, and mouth. So these all are the informations are fed into the system. You just give lot of photos into a computer and write a artificial intelligence program, ask the system to learn how the human face will look like. So based on the resolution, it can zoom the photo, it can increase the brightness, it can do orientation, it does lot of work on the human face, human photo, and it will extract the information from the human face, and finally it will define, okay, if there is something like this object found on the photo, then it will be a human face. This is how the face recognition works, and that program is taken and injected into the camera application so that your camera application is detecting your face. So there is an artificial intelligence program called face recognition running on the mobile phone's camera, right? So how this happens? That is called image classification. As I was saying, you need to give lot of data to the system and ask the system to learn. System, I'm saying it is a computer, it can be a server or it can be a computer. So ideally it should be a server, computer server, right? You need to give lot of images to the system, and you train the system if you are feeding. So for example, the screen what you are seeing is different photo of dog. So there are different photos, different variety of dogs. So the system will understand, okay, whenever I'm seeing a photo something like this, it will be a dog. And in the back end, it will take the photo, it will divide into multiple small pixels, and it will store it in the back end. And using the deep neural network, it will find out whether it is dog or cat, it is dog or not, when you're using in an application. So you might be wondering, so what is the big science here? Whenever you see a photo of dog, yeah, it is a dog. So what extra the system is doing? So you might be thinking in that manner, right? So just take an example. So still I'm just trying to explain you the difference between the machine learning and deep learning. Machine learning is something, feature extraction is done by the programmer, is done by the human. So for example, you take a car and you take out the feature of the car. So every car has wheel is in the size of round, and the doors and the glasses and the headlights. So there are different features for a car. So you need to extract each and every feature of the car, and you tell the system, if you see something like this, then it will be a car. If it is not, it is not car. So that is the machine learning. And in the deep learning, when you feed in the number of cars photo, the system itself, the deep neural network itself, will extract automatically the feature of the object what you are feeding, and it will classify, and it will tell you, when you are using it, it will tell you whether the input is car or not. Right. So this is how the feature extraction in the classification. So let's even take another example, a tomato or a cherry, right? So the feature is something like size, the type of the stem. So there is a size difference between a tomato and a cherry, right? So tomato may be a bigger in size and cherry will be smaller in size. The type of stem is something different for tomato and.
Senthil, sorry, I think you need to re-present. I think your presentation was stopped.
Okay.
Yeah, just restart the presentation. Yeah.
Yeah, continue, sir. Continue, sir. Presentation is on.
Yeah, let me just put on the presentation as well. So,
Yeah. Muthukumar sir, please your video கொஞ்சம் பாருங்க.
Yeah, it's fine now.
okay,
Yeah,
can
it's
you
fine. It's fine.
yeah, okay. Thanks for reminding me. Okay, so yeah, I was talking about the feature extraction. So once you are done with the feature extraction, and the deep neural network will tell you the image is the tomato or cherry. But for that, you need to feed in lot of data, lot of picture of a tomato and a cherry, so that the system will understand. Because a tomato cannot be in the same size, same color for all time, right? So a tomato can be a different size, different color. The stem will be in a different size, different color. So as much as the data you train the system, and that much accuracy your result will be. So that is been done in the deep learning using deep neural network, right? So yeah, still I'm talking about a car, dog, and cherry, tomato. It is all basic things. So you might be wondering, this all basic thing. But what I'm trying to tell you is, this is the basic concept, and I'll tell you where it is exactly, or one of the places it is used, right? So it is the one use case is chasing a stolen car, right? You go to a police and complain, okay, my car is stolen, somebody stole my car, right? So for that, the police department can use this technology to chase where your car is. Because every street we have the CCTV cameras. So with that footage, a police department can try to chase where the stolen car is, and it will be useful for finding a thief also. These are the real-time use cases. But in the back end, the concept is still the image classification, is the artificial intelligence code which is running in behind. So these are the real-time use cases. So I was giving you the tomato or car example to make you understand what this really does in the back end when you are running a deep neural network. But actual use case, this is one of the actual use case, right? So when there is a multi-object classification, so this is a kind of extracting the text. People does write in a different way of writing. So the example what you're seeing on the screen, a person is writing a number 9. It is not necessarily that every person write 9 as it is supposed to be, right? It can be in a different manner. As a man, if you are looking at, we know, okay, this is 9. But as a computer, it doesn't know whether it is 9 or not, because it is written by the human. A computer knows a 9 is something it is taught to, 9 is something like that only. But a human, we can write it in a different way, right? But what the artificial intelligence does is making the system understands, even you write a number in a different format, still it will understand that is the number 9. People who are not talking can go on mute, please.
नेटवर्क हो गया
Praveen sir, can you mute others?
Yes, sir, I will do it.
Okay. Okay. Yeah, I was talking about the neural network, how it does is. So when you're scanning a paper, so it is just a scan. The scan will be just an image. But how will you extract the number if you have written number, and if you have written a text? People write in a different way. But how the system will understand this is 5, this is 9, this is A, this is B? Because there is a artificial intelligence program runs in the backend, kind of the multi-object classification. When you see in the screen, the numbers, various numbers, 7, 1, 9, whatever the number, the convolutional layers, there are different layers in the deep neural network. It will extract, it will divide the image into multiple pixels, and it will store. Finally, it will tell you what number it is. So this is how the system is understanding what the number is. Otherwise, the system won't even understand if you write in a different angle of a number or a text, right? So similarly, for the face recognition, first in the first slide I was talking about just extracting the feature of a person. If it is eyes, if there is a nose, if there is a mouth, then it is a human face. That is all it could understand. It is going little bit deeper to understand the particular person's identity. So you just feed in lot of photo of yours, and finally it will tell you, once the system learned how your particular person's face. For example, you are just feeding lot of the Prime Minister's photo, right? The system will understand if face is, if eyebrow is something like this, if eyes is something like this, if nose, combining all together, if it is matching all the requirement, then it will be the Prime Minister. So something like that. It is not detecting only the human face, but it can go little bit deeper and it can tell you who that is by still extracting the features of the face and go to multi-level of the deep neural network, and finally it will give you a expected output. So then again, where it is useful, a fraud detection. So you have, again I'm going to the same example which I have given. Police department, they will be having the number of criminal photo. So when there is a theft happened, you will have the CCTV footage, and from there you can match the CCTV footage with the number of faces, number of criminal face images what the police department is maintaining. You can match and find who has involved in that theft. So this is one of the use cases. And similarly, you take a photo of different products. You just feed into the system. The system will tell you what product it is and the information about the product. These kind of technology will be used for the marketing. And the other is visual search. You're going into shopping, into a shop, and then you see a bag, for example, in the screen, but you don't know what is the bag is all about. You don't know what is the brand, you don't know what is the price, you don't know what the bag is made of, you never know what is it. You just take a photo and search it in the web. So that is an artificial intelligence. The same, the image classification example which I was talked about, the system will go and search what the bag is, and it will find what the brand is, what is the model, and what is the color, what is the price, everything, the information what you want. So when you're looking at a bare eye, you will not know actually there is an artificial intelligence program is running in behind. So these all are the real-time use cases what is there in the current industry, right? So the other artificial intelligence concept is natural language processing, which is NLP. So there are different way of NLP, natural language processing. First thing is text, and the second is voice recognition, right? I hope most of you people are using the Google Home Mini or Amazon Alexa or Apple iPhone Siri. So these all are the real-time example where the NLP, the natural language processing technique of AI is used in the backend, right? So when you're asking something, the Amazon Alexa or Google Assistant, hey Google, what is your name? So that means people who talks in a different way, but there is a artificial intelligence program running on the Amazon Alexa or Google Assistants. It will understand the way you're talking, and it has to understand what it is supposed to do, right? You will never know that there is a artificial intelligence program runs in the backend. It's all uses the concept called NLP, natural language processing, right? It has its own intelligence. When you ask for the Google Assistants or Amazon Alexa, like, hey Google, order me a pizza. So the pizza can be like this. So the Alexa has to have an intelligence. Okay, so this person is asking me to order a pizza. So then the Alexa needs to find what is the pizza delivery shop is in the area, and it has to know the phone number of it, and it has to call them and order on behalf of you. This all, everything done by the artificial intelligence program, right? When you're asking to play music, so hey Google, play me a music from this particular movie, this song. So first thing, the AI needs to understand what you're talking first. So what is the word you're saying? It has to listen from what you're talking, and it has to convert what you're talking from the voice to the text, and it has to understand and take an action. So this all happens in the backend by AI program using NLP, natural language processing, right? Similarly, a text processing, right? There are multiple algorithms for natural language processing, maybe like Bayesian network or support vector machines. There are various algorithms, but we don't have to go in depth about algorithm, but we just need to know how it works. Hope you people all are some way or the other, you would have seen chatbots. Even I can give you an example. IRCTC, you know, this is the online portal from for booking the railway tickets. And have you any time noticed there is a chat bot in the right bottom of the corner? I don't remember what is the name of the chat bot. There is something, some name. So what it does for you, whenever you are asking a question like, how can I book a ticket in IRCTC? It will tell you the answer. So that means there is nobody sitting in the back end when you're asking, when you're chatting something, there is no real human sitting in the back end giving you an answer. There is a chatbot running in the back end, and the chatbot will understand what you're asking, and it will give you an appropriate answer to you, right? So for that, the program, the AI program, which is using the NLP, natural language processing, it will uses the algorithm, something like Bayesian network or support vector. This uses this kind of algorithm, and it understands what is your question and answers accordingly, right? So here basically the usage is, you don't have to deploy a human and pay him some money just for answering a simple question. So if it is complex, yeah, a machine cannot answer. But list of hundreds of questions, a simple question, to answer a simple question, you don't have to deploy a human in the back end. You don't have to waste a human resource. Instead of, you can use a chatbot, right? This will decrease the expense. So that is the one of the use cases for the natural language processing. And okay, I have 10-15 minutes more. Yep, I have 10 more slides. Okay, so how the AI used in the science? All the area of science, still the artificial intelligence is used. I don't have time to explain all of them. So basically, I can give you the current scenario. We all are coming across a scenario, the corona, the COVID-19 virus. So for that, the expert team is working on how we can use the artificial intelligence to overcome this COVID-19, because still the drug is not discovered and there is no vaccine is discovered, and the research team and the scientist team still working on how to find a drug for this. Using one way or the other, the artificial intelligence program is used for the drug discovery along with the high performance computing. And for the prevention, maybe you can see in the screen. In the camera itself, you can get to know using the data what the system has to find out the temperature of a person, right? So these are all the latest happenings, latest researches in the industry for the COVID-19 or the coronavirus case. So the artificial intelligence, the point is AI is there on the science as well. So how it is used, the AI is used on the factories and the for a there is a huge noise in the back. Can somebody?
Sudha D, please.
Thank you. And so, yeah, on the manufacturing, there is a quality control department. So there is a quality control manager, and they'll be checking the products. Each product is manufactured whether they are in quality or not. So for that, again, you can use the AI, the machine learning and deep learning, to find out whether the product is into the better quality or not, right? So you take this the right hand side example, a Coca-Cola bottle, right? So on the first photo, what you see, the Coca-Cola bottle is fine, but the logo is not up to the mark. It is not right. So the system is detecting 78%. The system finds it is a Coca-Cola bottle because the AI program, the system is taught using the AI program is how the Coca-Cola bottle will look like. With thousands of images of Coca-Cola bottle, we train the system. This is how the Coca-Cola bottle should look like. And you are giving the quality audit camera where it finds this Coca-Cola bottle is 78%. It found, yes, this is a Coca-Cola bottle, but 22% it is a defected product because the logo is not right. And the second thing is, on the second image, the system found 70% of this Coca-Cola bottle is defect, because it is a defected product. That bottle is dent, so it cannot be used. It is a defect bottle, so the system will tells you it is a defected, so you need to go and replace it. So for that, you don't have to deploy a human audit control person. Instead, you can do the artificial intelligence program and feed into the camera which is there on the factory, and that itself will tell you that whether that product is full qualified for export or not. In the last one, it says yes, 97% it is a Coca-Cola bottle and it is fine, right? So this is how it is used for a better quality control and for automation, right? In the factories, people does same thing again and again. So just fixing a chip in a particular place, people just be on the line and then do the same work again and again. So doing same work, same manner, you don't have to deploy a person. Instead, you ask a system to do this, right? So for that machine, you just make and teach the system, this is how you need to do this particular work. Once you taught it with different number of inputs, and then it can work on its own, and it can do the work for you automatically. So you don't have to deploy a person, a human, for that work, because there is no intelligence needed. It is just a work repeatedly to be done. That's it, right? This is for automation. And again, the defect detection in a factory, whether you have a product, there are a number of screws, and if there is one screw is not fitting properly, then it will be a problem when you're selling the product, right? So it will be a problem when the product is getting used. So for that, all you have to do is train the system. Something in the screen what you see, you train the system, a screw is something like this, then it is proper. If it is not, it is not improper, you need to work on it to make it proper. So these all are used for defect detection or a better quality control. And if you think about the other way, we know the tropical cyclones, we know the weather prediction is done by the high performance computing, but artificial intelligence also involved here to detect how the cyclones are forming, whether you will get rain or not. There is the other way, using artificial intelligence program you can predict the weather, because we have satellite. The satellite is taking the image of atmosphere every seconds. So that means tons and tons of satellite images are stored or is there with the government. What they can do with the past history. Okay, for example, last April, last May, on this particular date, the satellite image was like this. Maybe like last May 15th, the image was like this, and 16th there was a rain. Similarly, 1997, similar, the same day, May 15th, there was a satellite image was like this, where it is forming the cyclone. Next day it was rain. So with the past history of the cyclones, you can predict the how the cyclone is forming, and whether you can predict. Based on that, you can predict whether it is going to rain tomorrow or not. So this is being used in the area of weather prediction as well. So yes, so we have seen number of examples, number of techniques, number of algorithms works in the artificial intelligence. To do that, yes, basically you need to have lot of big data. So that means you need to have lot of data, and you need to have lot of computers, basically servers. You need to have to train the system, and finally the inference is called deploying, where it has to be working. So this is how the typical workflow will be, right? So deploy an end-to-end AI system, you need to have lot of computational power, maybe a CPU or a GPU, lot of graphic processing unit. You need to have lot of storage, like hundreds of petabyte of storage capacity to store the data, and you need to connect a lot of servers using network. And when your workload increases, the number of CPU requirement increases, and the number of server requirement increases. And this is how the typical artificial intelligence training setup will look like. Yep. So yep, you have seen, but yeah, this is a bit of basic, but you know, like, so now you are thinking, okay, is it a war between artificial intelligence robot versus human? So you will be wondering. So there will be a question in the mind. Okay, so in future, all AI will replace the human, and AI will do the work. AI robot will do the work, but all the man will be losing. No, it is not really, because the AI cannot work on its own. The AI robots or the deep learning or the machine learning cannot operate its own, because it needs the human intelligence. The human intelligence should be taught to the system to reduce the workload of the human. So the artificial intelligence cannot replace the human intelligence. It can, both can work together to create a smarter planet. So that is it. What we have seen is just tip of the iceberg. There are a lot of things happening in the industry, and it is still in the development. A lot of things are already implemented, and a lot of researchers are going in the industry. So in the future, you will get a lot more about it. Yeah, so that's it from my side for today. And if you have Any question? You can shoot it right away.
Taken subjects.
Good morning, Senthil.
Good morning, sir.
Hello.
Please one by one. Please
yeah.
one by one ask your question.
Sir, this is Dr. Arun Kulkarni from Ballari. Hello.
Good morning, sir.
Sir, if we compare the robot with the human brain, which is superior, sir?
Yeah, that is exactly I mentioned in my last slide. You cannot compare the human brain with the robot, because robot is just a machine. It doesn't know anything. It is just a number of chips. As a human, we are teaching the robot what to do. Otherwise, robot cannot do. Robot is just a machine. If we are not teaching the machine, we are not programming that robot, it doesn't know anything. So the robot is designed by the human brain. So there is no comparison between the human brain and the robot's brain, because human brain is always superior, and we are teaching the robot to do what it's supposed to do. Because robot is not so intelligent. If you are teaching a robot to do your daily work, for example, a cropping work or daily work, like just feeding the lawn, it can do only that work. It doesn't know anything more than that. As long as we teach the robot, then only it will understand what it is do. Otherwise, it doesn't know anything. So there is nothing called robot is superior than human. Human brain is always superior.
Thank you, sir.
Yeah, sure.
Sir.
Yes,
Next,
sir.
yeah.
Good morning, sir. Hello. Yes, sir.
Yes, sir. Go ahead.
Yeah. Good morning, sir. I am Professor Vidyabudi from VIT University. My question is about what are the computational challenges? Because when we talk about AI and deep learning and all, what about the computational challenges to meet the computational requirement in terms of hardware or software, whatever we are talking about? Yeah.
Yeah. So in terms of hardware, based on the training, the AI training you are using, based on the size of the data you use to train the system, huge number of servers and the number of CPUs will be required. On top of that, what technique? So what I'm taught or teaching today is the concept of artificial intelligence. So for example, the image classification or object detection or NLP, natural language processing, these all are concepts. In the behind, there are frameworks which is designed by Google, Microsoft, Amazon. There are number of frameworks available on the software side. So as a data scientist, we need to use those pre-built frameworks and the libraries, feed into the number of servers which is connected. So in the last slide, I just shown how many number of servers, so that there is no definite number of servers, definite number of processes. It is all based on the data, how much you have. For example, you have 1 GB of data. Only 1 GB of data you are using for training the system. That may need just 4 CPU, for example. If you have 1 terabyte of data, then you will have some hundreds of CPU. Similarly, you have 1 petabyte of data set, you will have like thousands of GPUs and CPU. It is all based on the size of data what you're having to train the system. It's all based on the requirement. There is no like straightforward formula to calculate. It is all based on the data, how much you have.
Yes, sir. Thank you. Thank you.
Thank you. Next question.
Senthil, I think there are a lot of questions on the chat window. You want to follow that?
Okay.
Kamra sir, please ask questions in chat box.
Yeah, the first question is which language? Kamraj, I can take it up, no problem. Sorry. So which language is used for AI? It's a question from Ms. Soumya M.
Okay, so language, you know, there are languages like C, C++. No, they are programming languages, and here what it is used are all our algorithms. Those algorithms are written by R programming or a Python programming. So there is no the low-level language or high-level language like C, Java. No, it is not used. Here, all are Python or R programming, or Python.
Yeah. Basically, the frameworks for different learning, right? Okay.
Yeah.
So the next question came from Mr. Suresh Daman. The question is, can you give a difference of AI and machine learning, deep learning with a single example?
With a single example, yes. So in the slide, when I was talking about the difference between machine learning and deep learning. So under AI, artificial intelligence only, machine learning and deep learning comes, right? Machine learning is the human programming involves to extract the feature of an input. But deep learning uses the deep neural network and it will extract the feature of the input automatically. That is the difference between machine learning and deep learning. Both of these comes under artificial intelligence as a bigger umbrella. Under artificial intelligence, you have two methods: machine learning and deep learning. So you cannot differentiate deep learning and artificial, because artificial intelligence has machine learning and deep learning inside.
Okay.
Next question.
Okay, sir, one more question. Sudha. Hello.
Yes, sir. Go ahead.
Why Python is preferred?
Now, Python is the way of you can use the Python to code the artificial intelligence code, because there are a number of frameworks written by, as I mentioned, there are a number of frameworks like TensorFlow. You can still go ahead and search TensorFlow, Cafe, Neon. There are a number of frameworks designed by the big companies like Amazon, Google. They have written already number of pre-built libraries. If you have to use those libraries, Python is the way you can import all those libraries. So that's the reason Python is used for this programming.
One more question.
Yep.
Which software is better to do programming in TL, MATLAB or Python? From one more person.
Python. Python.
Another question from Sarathi Raji. Differentiate DNN and CNN.
Deep neural network and CNN you are referring to?
Satyaraji.
Sir, a convolutional neural network.
Okay, so convolutional neural network, that is again, convolutional neural network comes in the machine learning. So where again, so the same explanation applies here also. On the convolutional neural network, still you need to extract the feature of the data. It cannot extract the feature of the input data on its own. But in the deep neural network, it can extract the feature on its own with multiple number of hidden layers in between, so that it can extract the feature on its own. But in the convolutional neural network, on the machine learning, as a programmer, we need to extract the feature of the input what we are feeding to the system.
Good, sir. Very nice. And there is another question from Jabin Banu. Comparison between blockchain, AI, and big data.
Okay, so blockchain is the data which is not stored in a common place. So, for example, okay, so we are doing the land registrations, right? The land registration information, if it is stored in if it is digitalized, if there is no land, the registration paper, there is no hard paper, if it is stored in a digitized environment, anybody can go ahead and change it. If it is same copy, if it is stored on a multiple location, even there is somebody go ahead and change it in one place, but there are number of other places which has same data in common, and you can find out which is the right data, right? So on the blockchain, where the data is replicated in multiple places, still if there is one place, if it is corrupted, still you can have the comparison of the other places. So it is connected as a chain. The use case of blockchain, like the digital currencies, all those things are there on blockchain. But here in the artificial intelligence, as I explained already, you are teaching a machine to think of more than what it does. A machine, as again given an example, a machine can do certain number of words. It cannot think more than that. Basically, the Alexa can do more than what the system, what the hardware can do, because it is able to think. If you are asking something, it is going and searching, and it is giving you an answer based on your question. So it is able to think on its own. So that is taught by the machine learning and deep learning in the intelligence.
Sir, participants, please mute your audio.
Yes, please. Yeah, please.
Yeah, very nice question and
Sir, one more question. Actually, sir.
Continue, Praveen.
Yeah. One more question from Satvika R. Sir, is it only one particular computer language is used for designing an AI system, or combination of computer languages?
No, there is nothing hard fast rule. You need to use only one language, because currently the frameworks designed by these big companies, the libraries which are available on Python and R programming. But in future, again, there are a lot of developments are going to use some other programming model, programming methods also into this to expand the usage of the AI. So there is no hard fast rule to use only one programming language. There are multiple. Yeah. So for now, again, the research is going on.
Sir, one more question is from Divya. Tell us something about AI searching method.
Searching. So what kind of searching? So I was talking about the natural language processing. The NLP is used when you are using a Google search. You're simply searching something on the Google, but the Google has to use the NLP, natural language processing, to process the text what you have entered into the Google, and it has to search in the backend, and it will give you the relevant results for you. That is one way of searching. That is a text searching. The other way, image searching, for that there's a image classification. That's a different way of doing AI. So it is based on what kind of search you do. And even voice search also is there. So that's also uses NLP, but in the backend it uses different algorithm. The algorithm which I was talking about, there are number of algorithms. Under NLP, one algorithm will be used for text processing, the other algorithm will be used for the language processing, the voice processing. So there are a number of algorithms used behind.
Sir, one more question from Periyasamy PN. Sir, what is supervised learning and unsupervised learning?
So supervised learning means you need to supervise the system. Still again, when you are telling the system to do something, there is a supervision needed. For example, I can give another example. Like there is a thermometer, right? You're all using in home. When you're inside the home, the thermometer should understand there is a AI program feed into the thermometer where it understands, okay, somebody is coming, let me go ahead and automatically switch on the AC. So that is supervised AI. If it is, when it is unsupervised learning, the thermometer will think even more than that. When somebody is entering into the home, then the supervised and unsupervised one will detect who has entered. Based on the person, it will again tune the AC to a particular degree. So supervised learning is something basic it does, and unsupervised learning without human intervention, it does a lot of things. Again, another example is the Tesla Autopilot. Right? Tesla, you all know Tesla's Autopilot. Without a driver, the AI program drive a car without human intervention. So that means that AI program has to know the traffic rules and the road condition, and it has to understand the map, and it has to understand the nearest vehicle using the sensors. So that is unsupervised learning, because it owns each and every thing which is required to drive a car.